remaining questions. See your last year paper. Question number 68. Question number 68. The shape of XeFi molecule will be the shape of XeF5 minus. Now, yesterday I told about shape of the molecules, how to determine, how to find the geometry or shape of the molecule by calculating the number of hybrid orbitals and knowing the type of hybridization and finally shape of the molecule. And if number of hybrid orbitals obtained equal to 2, it is called sp hybridized and linear structure. If orbital number is 3, sp2 triangular planar, and 4 no lone pairs, sp3 tetrahedral, 4 1 lone pair, sp3 pyramidal, 4 sp3 but 2 lone pairs, then it is said to be what? sp3 bent structure. So like that I told, based on that method, now we can decide geometry of the molecule. Therefore, number of hybrid orbitals equal to number of sigma bonds plus half into Ve minus number of covalent bonds. Number of sigma bonds in XeFi 5, because it is monovalent, same number. Divalent 5, even for divalent sigma bond you have to write first. Divalent or trivalent, but sigma bond one type 5 plus number of lone pairs. Number of lone pairs. See how to find them. Valence electrons of Xe are any noble gas, helium, neon, except helium, neon, argon, krypton, xenon, and radon. They have 8 outermost electrons because halogens 7 electron and noble gases 8. Therefore, 8 valence electron, but there is negative. Therefore, 1 electron added. If it is negative, 1 electron added, minus covalent bonds 5. Total number of covalent bonds equal to 5. Therefore, 5 plus 8 plus 1, 9. 9 minus 4, sorry, 9 minus 5, 4. 4 by 2, 2. Now remember, there are 2 lone pairs. 2 lone pairs. But total value found to be 7. Therefore, it is called sp3 4 plus 3 7. sp3d3. If you get sp3d3, then it is said to be what? Pentagonal bipyramidal. It is called pentagonal bipyramidal. Two, 3, 4, 5, 6, 7, and 8. Actually, it contains 2 lone pairs. Xe F5, 1, 2, 3, 4, 5, and lone pair. Actually, there are 2 lone pairs. 1 lone pair, 2 lone pair, 3 lone pair. One more lone pair. You can show like this. But actually it contains 2 lone pairs. Anyway, sp3d3 structure geometry, it's hybridizing sp3d3 and its geometry found to be pentagonal bipyramidal. Answer 4. They give square pyramid, trigonal bipyramidal, planar, etc. But answer pentagonal bipyramidal. Answer 4. Next, one more question. Again, based on the MOT, leave that one. because already I have repeated MOT question many times. Now see question number 61. Question number 61. Which of the following species contain equal number of sigma and pi bonds? Equal number of sigma and pi bonds. Option number 1, HCO3 minus. You know how to draw structure? HCO3 minus bicarbonate ion. H2CO3 carbonic acid, and this one HCO3 minus ion. But this contains one pi bond. Sigma bond 3. Therefore, we cannot say answer first. XeO4. Then now only I told Xe contain 4 lone pairs. Therefore, it can form therefore 4 sigma and 4 pi. This contain 4 sigma bond, 4 pi bond. Answer second. But in case of cyanides, option number 3, Cn twice given. Then it can be written as 1, 2, 3, 4, 4 pi sigma 1, 2, 3. 4 pi bond, 3 sigma bond in option number 3rd. Option 4, CH2 Cn twice. CH2 Cn twice. 2 pi bonds, total 4 pi bond, 1, 2, 3, 4, 5, 6 sigma bond. Then answer second. In second option, 4 sigma, 4 pi. So by writing structural formulas, we can decide how many pi bonds are there in these species. Then isostructure, one more important question. Question number 62. Question number 62. Which of the following pairs of ions are isoelectronic and isostructural? See here, CO3 2 minus, SO3 2 minus, ClO3 minus, NO3 minus, NO3 minus. Isostructural, isoelectronic. They ask 2 points, number of electrons and structural formula. Now electrons in carbonate, 6 plus 3 into 8. Number of electrons, how to calculate? By adding the atomic numbers. 6 is the atomic number of C, 8 is the atomic number of O. 8 into 3, 24. 24. 2 minus 2 electron added. Therefore, it is 32 electron. 32 electron system. Then CO3 2 minus, whether tetrahedral, pyramidal, that we study afterwards based on the calculation of number of hybrid orbitals. Then SO3, atomic number of S 16, 8 into 3, 24 plus 2, 24, 30, 40, 42. Second one, 42 electron system. Whether CO3, SO3 isoelectronic? No. They are not said to be isoelectronic. Next, ClO3, 17 plus 8 into 3, 24 minus means plus electron. 24 plus 1, 25, 25 plus 7, 30 to 42. This is SO3, ClO3 both are isoelectronic. But one more point they give, isostructural, isoelectronic as well as isostructural. Then last one, N7 plus 3 into 8, 24 plus 1, 25 plus 7, 32. 32, 32. CO3, NO3 combination. CO3, NO3 combination not given. Next, SO3, ClO3. Right. SO3, ClO3. Then, but these you have to select. Selected. And isoelectronic also we proved. But isostructural, and to find isostructural, yes, what would we find out? Number of hybrid orbitals. Number of sigma bond plus half into VE minus number of covalent bonds. In case of ClO3 minus, this one I am calculating. Number of sigma bond in ClO3, 3 sigma plus half into various electrons here Cl7 plus 1 electron minus covalent bonds 3 into 2, 3 plus 7 plus 1, 8, 8 minus 6, 2, 2 by 2, 1, 4, sp3. ClO3, we get sp3 hybridized, but one lone pair. If it is sp3 hybridized, one lone pair, this is actually lone pair. If you have a lone pair, that is called pyramidal. Yes. Geometry of ClO3, pyramidal. Then similarly for SO3. SO3 covalent bonds 3 plus 1 by 2 bracket various electrons of S6, 2 electrons are added minus 6. Number of covalent bonds 3 into 2, 6. Then 6 plus 2, 8. 8 minus 6, 2. 2 by 2, 1. 4 sp3. sp3 4, correct, but one lone pair. Because of one lone pair, it is called pyramidal. Just to answer such questions, you should have knowledge about calculating the number of hybrid orbitals, plus based on the hybrid orbital we can write type of hybridization, and based on the lone pair we can decide geometry of the molecule. So this is one of the important questions appeared in many papers, previous year papers. And similarly, question number 64 in last class about formal charge I told in ozone. O is linked with single bond -1, double bond O 0, and a central atom O +1. Therefore, answer question number 64, answer is 2. Regarding dipole moments, today also I covered dipole moment. Question number 65. Question number 65. About dipole moment they are asking. The compound that will have a permanent dipole moment among the following is. Now see here. 1. Second, this is the 1. Second structure. (1,2-dichloroethene). Third structure, carbon tetrachloride, fourth structure, 1,2-dibromoethane. 1,2-dibromoethane. So these are the molecules. 4 molecules are given to you. Now decide which is said to be polar, non-polar, and also having dipole moments. In first option, dipole moment towards Cl here, and here less electronegative, and carbon less electronegative than Cl. Therefore, it has a resultant dipole moment. Mu value not equal to 0, but Cl opposite. Therefore, dipole moment cancel. This also opposite. Therefore, for trans isomer, mu value found to be 0. Then CCl4 opposite and symmetrical, then 0. Linear opposite CBr, mu value 0. Therefore, answer 1 only means structure this. This is correct. Okay. Then about bond orders, again same, repeat, bond order, bond angle, etc. Same type, means MOT questions are more, and practice well MOT in this topic. Then in question bank, question multiple choice question. Which of the following shows the Levy's dot formula? Even in the first hour only I told regarding Levy's dot structures, and see few questions based on this. Levy's dot formula. Question number 1, multiple choice. Which of the following shows the Levy's dot structure for CO2? So any question they can ask about Levy's dot structure. Better write same formula CO, because we know CO2 has but linear structure, and write valence electrons around C 1, 2, 3, 4. Next 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because O valence electrons are 6. C 4. Then 2 electrons from O, 2 electrons from C. Yes, so like this. Over. It can form double bond O, double bond O. Don't write bonds. We show only valence electrons and with bond type. So this is the Levy's dot structure for CO2. So answer 1. First option is correct. Then again they asked here dipole moment S2O, S2S, BF3. Question number 3. It is covered in today's class only. Question number 5, MOT. How many orbitals are singly occupied in O2 molecule? Singly occupied in O2 molecule. And there we studied pi star 2px1, pi star 2py1. They are singly occupied. Remaining all orbitals are what? Doubly occupied. Therefore, answer is first. Then regarding ionic character and covalent character, electronegativity difference, if we get less than 1.7, it is called covalent. More than 1.7, ionic. More than 1.7, ionic. Therefore, they asked about ionic. Answer is 2. If the difference in electronegativities of X and Y is more than 1.7, then it is said to be ionic character. Similarly, which of the following pairs are isostructural? Yes. That practice paper, there I told isostructural and isoelectronic both. How to decide isostructural? SO4 2 minus, BF4 minus. Question number 9. NS3, NS4 plus. But here all the molecules are different. And using that method, let's try to solve this one, question number 9, and all of you get answer. For this, answer is 1. Because SO4 tetrahedral, BF4 also tetrahedral, and then we get sp3, means number of hybrid orbitals equal to 4. There is a number of lone pairs we get 0. In that case, that's why answer is 1. Similarly, question number 10. Which of the following molecules is formed by sp2 hybrid orbitals? sp2, they are asking sp2. Now all of you know about the molecules. First option, CH4. CH4. It is alkane, and in alkanes, carbon is sp3 hybridized, but they are asking sp2. Second option, CO2. CO2, linear. 2 pi bonds are there, linear, therefore it is called sp. CO2 sp, CH4 sp3. But boron trifluoride, BF3. Boron, atom number 5, 1s2, 2s2, 2p1. For this we can write excited state, electron jumps here. Then sp2 hybridized. Boron trifluoride, sp2 hybridized. Beryllium fluoride, BeF2. BeF2. 4, 1s2, 2s1, 2p1. Excited state, 1s, 1p, sp. It is linear. Therefore, answer is 3. Like this, more questions are simple. You can read all the questions, but whatever important points are there, I have covered in chemical bonding topic. So, chemical bonding or any topics in inorganic chemistry, yes, all are simple and if you know fundamentals of chemistry, you can answer many questions like electronegativity, bond length, bond angles, bond order, bond dissociation enthalpies, stability of molecules, electronic configuration of atoms, and electron configuration of molecules. If you know all these fundamentals, then we can answer many questions in inorganic chemistry. So in the next unit, we can study about the structure of atom, periodicity and periodic table, and about environmental pollution. And there, in that unit, there is a structure of atom. Structure of atom. In that, quantum numbers I have to explain, because most of the things that is there in physics, but important quantum numbers I have to explain, because more questions based on quantum number. Every year you can see previous year papers, there is one question based on quantum numbers, and that I want to cover from structure of atom. And about periodic table also I will give you brief note on that topic, and pollution topic is general that you can read. But in the next video I will explain structure of atom. Okay.